Question 3 in the Working with Data in R activity just deals with factors. Now, categorical variables are all over the place in business analytics, like gender, marital status, relative income group, like wealthy, poor, middle class. And so it's going to be necessary for us to be experts at manipulating factors, redefining levels, combining levels, all these things, for us to be proficient in data analytics here. So number 3 asked us to start out by defining a vector named f in the following way. I've written this code here, so we're just going to run it. And let's talk about what it does. This first line right here sets the random number seed at the position 400. Now, why do we do this? Well, I'm going to be generating a sample of letters essentially randomly, and I want to make sure that we're all getting the same set of letters here. They're going to be randomly picked, but we're all going to get the same set, and I can guarantee that will be the case if I set the random number seed right before I run any command that invokes some sort of randomness. So once I've set the seed to 400, this next command will generate a factor of a whole bunch of randomly picked letters. How does this work? Well, the sample command is something we'll find to be really quite useful. For now, we don't care about too much how it works, but basically what it's doing is it's looking at the first arguments, letters, which happens to be a vector of all the lowercase letters, and it's going to pick 50 elements from this vector here with replacement. That's what that sample command does. That's where the randomness comes in, and we're going to treat that as a factor, and so we convert that into a factor with the factor command. So there's f, here is my data here are all the levels, and so let me run that one more time just so that you can see. Let me run it one more time. There we go. So now that I ran this, setting the seed to 400, make sure that we get the same results each time. If I don't set the random number seed ahead of time, well, I could get a completely different set of stuff. So for this class, obviously, I want you to know what the right answer is going to be. We'll be setting the random number seed a lot for reproducibility. All right, question A wants us to define a vector called z that contains the levels of f. All right, well, to define a variable, we say what the name of that variable is, z in this case. The left-hand arrow is going to define it to be something, and if we want it to be the levels of f, we can just use the levels command to extract the levels of our object named f. So if we run this, we see that a new value called z exists in the environment. Printing that out, we see it's a whole bunch of letters here. What type of data are treating this as? Let's ask the class of this data. We see it's a character vector. Its entries are simply just words or letters. It's not a factor. It's not an official categorical variable. It's being represented just as a vector of letters. All right, so now something more interesting. How many of the 26 letters are missing? So we have all the levels of f here stored in that variable z. I know at least one's missing because I don't see an f right here, but maybe there's some others missing as well. So one way to do this is to count up the number of elements in z here. That'll tell me how many letters exist in that factor f, and I can use that to get my answer. So if I were to say length of z, that tells me the number of entries in z, and it looks like there's 24. So there must be 2 missing letters. 26 minus this value will tell me the number of missing letters here. What are those missing letters? Well, I could scan through this list of letters and find that out. But as a bonus, let's write a command that actually figures out what letters are missing. So how are we going to do this? Well, we're going to use this, you're going to do this with the which command along with the %in shortcut. So how is this going to work? What are the letters that exist? Well, the letters vector has all of the letters from A to Z here. And what I'd like to know is there an A inside the vector Z, the levels of F? Is there a B? Is there a C? Is there a D? Etc. And so that's where the %in shortcut is going to be really quite useful. If I say letters %in z, what this will do is one by one go through the elements of this vector here on the left and check to see if that element is inside this vector z, whatever happens to be on the right-hand side of %in. And that will return a true if it finds it or a false if it doesn't find it. So let's preview what the answer is going to be. It looks to see, all right, is there an A inside the vector z? Yes, there is. True. Is there a B inside the vector z? There is. True. Is there a C inside the vector Z? There is, true. Is there an F inside the vector Z? No, there's not, false. So if we run just this little tiny command, we see that we get a vector of trues and falses for whether or not the corresponding element in the letters vector here was or was not inside the vector Z. So, okay, here's my chance to be clever. If I say which letters percentage in Z equals to false, what that will do is it'll go through and scour this vector of trues and falses and report the positions of the falses, basically the positions of the letters vector where that letter didn't happen to be in the vector Z here. So if I say which letters in N equals to false, it comes out and it says, all right, it looks like the 6th element and the 23rd element of this vector have falses. All right, so what is the 6th letter and the 23rd letter? Well, we can extract those positions from the letter vector itself by using the square brackets. So we find it's F and W that seem to be missing. And in fact, scanning through the last few elements of Z, the levels of F here, we don't see a W. W was indeed a missing level. All right, on to B. What position inside the vector Z is the letter Y? All right, well, if I just print out the elements in Z, I see that Y is the second to last element, the 23rd element in this case, so I know what the answer is, but let's do this more efficiently in R. I know that if I want to know what position a certain element is in, the which command will help me out here. So basically, which element of Z is equal to Y? Double equal sign because I'm checking whether something is something or is not something else. And Y is in double quotes because it is just a letter. It's not a variable or anything like that. If I say which Z double equals Y, it's going to say that the result is 23. The 23rd position in the vector Z is Y. All right, so use levels F in part of a command to rename the level Y to be both. Now, looking forward, basically what we're going to do is we're going to rename the levels to be vowel, consonant, or both, depending on what kind of letter it is. And Y goes both ways. It can be a vowel, it can be a consonant, so we're going to give it the name both. All right, how do we rename levels? Well, we say what the levels are that we want to be renaming. Basically, we want to be renaming the levels of F. Specifically, which level? Well, I want to rename the level Y. All right, so which position inside of this vector is equal to Y here? I can do something very similar to what I had written up here for the which command. I could say which levels of F are equal to Y. You'll notice that this will evaluate to 23. Basically, take the 23rd level of F, redefine it with the left-hand arrow symbol to be both. So now if I look at levels of F, I see that both is here instead of Y. If I look at the entries of F, Y actually appeared 2 times, so I see both in 2 positions. All right, so we did part B. Now let's do this for the vowels and the consonants as well. We'll basically just reuse this code that we've been doing. Use levels F in part of a command to rename the levels A, E, I, O, U to be vowel. All right, so we basically renamed one level to be both up here. Now in this case, we're going to be renaming multiple levels to be vowel. Which levels? Well, the ones that correspond to A, E, I, O, and U. All right, so instead of saying which levels F equals to Y, I want which levels of F are equal to A, or which levels of F are equal to E, or, and you can see this is going to be tedious. I'm going to have to type out all those things. Here's where the percentage in shortcut can save the day. So if I say which levels of F are inside the vector A, E, I, O, U, that'll go through systematically and look to see, all right, is that first element of the levels of F equal to A? If it is, then, all right, we're going to rename that vowel. Is the second level of F equal to A, E, I, O, or U? If it is, it'll rename that to vowel all the way down the list. So notice if I say which levels of F percentage in this vector here, I'm going to get a list of numbers out corresponding to the positions inside that levels vector that meet my condition I specified. So the first level is a vowel. Yes, it is. The fifth level is a value. Yep, vowel, that is. E, the eighth level, etc. So if I run this line now, we'll see that the levels of F, we have vowel, we have both, which we changed before. We don't see an A, we don't see an E, we don't see an I. All of those levels have been renamed to just vowel here. All right, so if I look at the entries of F, we see the consonants, we see some vowels, and we see both. That's where the Y's were. So whenever we see vowel, that must have either been an A, E, I, or a U to begin with. We've recoded those values here. And then finally for part 2, we're going to do that just for consonants. So basically doing this exact same thing here, except instead of extracting all the vowels out, extracting the consonants out, and renaming them consonant. Now, I'm not going to go through and type out every single consonant because that's a lot. So how could I do this more efficiently? Well, why don't I use the letters vector to help me out? If I look at letters, all right, it looks like the second, third, and fourth element are some consonants. All right, well, the fifth one's a vowel, but the sixth, seventh, and eighth are consonants. The ninth one is the I, so we can skip that. So then we get 10, 11, 12, 13, 14. Those are all consonants. 16, 17, 18, 19, 20. Consonants. And then finally 21 to 24. And then letters of 25. So, oops, letters of 26 would be Z. So what I could do is I could just make all these guys a vector. A little bit tedious. You know, I probably could have been better off just typing out all those consonants, but hey, practice, never a bad thing. So if I look at this, here indeed is my vector of consonants. Is that any shorter than actually typing them all out? Well, no, not really. But hey, this was a kind of a cool trick. So what I'm going to do is just something very similar. Which levels of F are somewhere inside this vector? These are all the consonants. Let's rename that to be consonant. So long command. Some of these commands get long. There's nothing you can do about it. Let's run that command. So if I look at levels of F, I see we only have vowels, consonants, or both. If I look at the entries of F, there we go. And if I want a frequency table of these three new levels of F now, why don't we get that with just the table command. Table, summary, same sort of thing with categorical variables. They both provide frequency tables. So we see 8 vowels, 40 consonants, and 2 instances where Y was there. All right, so it's just some mucking about with categorical variables. This was just purely illustrative, but you're going to be doing this task a lot. Combining levels, renaming levels. This is just part of the data cleaning process and something we have to get used to. So now that we're done, we can knit this to, say, an HTML file to verify that everything is finished. And it looks like we're pretty happy here. So there we go. There's our working with data in R activity.